This week, we have a number of topics to cover. Let's start with object equality and callback value. And let's review the learning outcomes first before we go on to the details. So by the end of this module, we will hope that you can learn about object equality, either to override or not to override. Again, kind of similar to how we handle the catch or specify requirements, either to handle or not to handle, right? So now we want to know for a particular class you design whether you want to override the equals method or not to override the equals method. We'll see detailed example later in the module. And we want to see how we can do asserting object equality in JUnit in the JUnit context. How you can write assertions such as assert same versus assert equals. There will be some cases for you to consider depending on whether you override the equals method or not of the classes in question. And we want to review what you actually learned in the first year called the short circuit effects, because in your equals method, typically you will have to use either the conjunction or disjunction. And that's something I would like to clarify before we can give you some exercise to think about. And we want to talk about the equality for array and also reference type attributes. For example, if you have an array of person in one of your classes, in that case, how do you define the equality for that particular class? So that's also something important to show you some example and also give you some exercise maybe as well. And we'll also talk about a small topic for called callback value. It's something that we did touch upon a little bit, but not really in detail when we did a review when we did a review tutorial series in the beginning of the course. Whenever you're trying to trace a method call, exactly how the argument values are actually passed into the method call to replace the parameters. That's something I did a little bit informally in the previous tracing, but in this lecture, we're gonna make it 100% clear. So that's the intention. We want to see your argument values in general can either be primitive value or it can be reference value, but they're gonna follow the same principle called callback value. That's something we'll go over in some detailed example as well. Okay, let's now talk about the first part. We want to talk about equality. Let's do a little bit review from what we have known already from the earlier learning. So let's recall. So a primitive variable stores a primitive value. For example, integer, Boolean, character, and also double, the floating point number, right? So these are the types that we learned about being primitive type. And for example, you got a double variable D1. And also you got a double variable D2, right? So they store, even though they store the same value over here, but they are different copies. And then what about reference variable? A reference variable stores the address to some objects. So we keep emphasizing it does not store the entire objects, which can be arbitrarily complicated for its object structure determined by its attributes. But in terms of the reference variable, for example, let's say here, if we say P1 is a reference variable, so P1 only store the address of the corresponding objects. For example, it's going to store the address of the point objects, which itself actually contains two attributes in this case, the X and also Y coordinates. That's what we have, right? That's something we also knew from before. And you can also have another variable here, just called P2, which stores the address of just another new point objects, right? So now, given that we got two cases, either we got primitive type variable D1 and D2, and we got reference type variables P1 and P2. How do we compare them? So that's really the essence about equality. So there are two notions of equality, either value equality or object equality. We'll get to there. Okay, so the binary operator equals may be applied to compare. Compare what? Let's see. In the case of primitive variables, so their values are compared. For example, if I do D1 equals D2, in this case, that will evaluate to true because we only compare the value 7.5 that is stored in D1. Compare that against another 7.5 which is stored in D2. And of course, these two values are the same. Okay, so that's why that will be just true. This one is easy. But in the case of reference variables, you got two possibilities. Either you can compare their reference, or you may compare their, I will quote, contents. Okay, but the contents over here, as we will learn in the later part of the module, the contents equality can be customized according to your need. That's something we need to learn as well. But let's talk about a little bit more generally. So the addresses they store are compared rather than comparing the contents of the object they refer to. So this is the easy case. If we simply say P1 equals P2, so that one will evaluate to false, because you can see P1 store the address of a new point object versus P2 stores the reference of just another object. So the values for the addresses are simply different. So that's why P1 equals P2 should evaluate to false. Okay, so that one is also something we knew from before. Okay, so make sure you understand what we have spoken about so far in the slides. I didn't do much visualization. I assume that's something you feel comfortable with, so we don't need to bother you with that. But we definitely do visualization for later. Okay, so what about object equality? You can see here I intentionally miss case number 2. Case number 1, so when you talk about reference variable P1 and P2, right? If you simply just want to compare their references, you would just use the equal, okay? But what if I want to compare the contents? I want to compare the contents being x being 2 and y being 3, and also for P2, also x being 2 and y being 3, even though they have different object addresses, but their contents are really the same. How can I actually make such comparison to compare their contents only rather than just their memory addresses? There is a way to do that. Okay. In order to do that, we need to give you some background about what's really the story about OOP, especially in Java. So implicitly in Java, let me just go over 2 bullet points, and then I'll give you some visualization as well. Every class, so when I say every class over here, it could be a class that you define in your projects, or it can be a class that comes from the Java API library, like arrays, like array list, or linked list, or maybe string class, right? So every class can either be customized by you, or can be from some existing Java collection, from some existing Java library. Every class is so-called a child or subclass of the object class. So here I talk about child and subclass over here. I'm already touching the topic of inheritance, but for the purpose of this week, I wouldn't really want to go much into detail about inheritance. We're going to cover that in the next module, next week, in much greater detail. But for this week, I just want to give you a little bit intuition. I think that should be sufficient. So it's a child or subclass of the object class. So object class is actually from the Java API, the Java library. So there's a class you should know. And then I'll show you a diagram in just a moment. The object class is the parents or superclass of every class. So you can think about it's the relation between child and parents. They are more like a bidirectional, it's like a symmetric relation. If you say one class is the child class of the object class, and apparently, symmetrically, object class is definitely the parent or superclass of that class. Okay, let's see one example right away over here. You can see here we try to draw more using like an inheritance relationship diagram. That's something I will also elaborate much more in detail later. You can think about at the top over here we have the class called objects. Underneath of that we actually got 2 sub or child classes for the purpose of this module. We got point version 1, also we got point version 2. So these are 2 separate classes that we're going to define under our Eclipse project. So they are implicitly or automatically the subclasses of the objects. So I would say point v1 and also point v2. They are both child classes or subclasses of the objects. Symmetrically, we say objects is the parent class of both the point v1 and also point v2, right? Just get familiar with the terminology I'm using, okay? And diagrammatically, we can also draw to say point v1 and also point v2 implicitly, since they are subclasses, so they extend their parent classes. Extend. We'll talk about the extend keyword when we talk about inheritance in just about a week or 2 weeks time. Okay, but for now, just understand extend simply means on the it's more like an arrow over here, and the direction really matters. On this end over here, that's the child. Okay, so this will be the child. On the other end, it's actually the parents. And you can also think about on the one end, it's like the subclass and also superclass, right? You can use parent class and superclass interchangeably. You can also use a child class and subclass interchangeably. Okay, we got these 2 classes. Okay, good for now, and let's now move on. And so there is a useful accessor method that every class inherits from the object class. So now the method is the equals method. We have already seen the equals method only in the context of comparing string values in the earlier review tutorial. But this lecture or this module here, we're going to see how we can redefine the equals method for any customized class you want to define. Okay, so you can think about in the object class, you actually got the equals method. It's more like an accessor. It will simply take just another object. It can be any object, basically, anything. And then it's going to return a Boolean, right? It's an accessor. By default, it has this simple definition. This equals obj, right? So how can we understand this? But I'm going to give you more example later. Equals over here tells you that it's going to compare references, right? It's going to compare addresses or references. Compare references or addresses of, number one, the context objects. You can see this is the context objects, right? It's going to be replaced by whatever context object you have when you have to trace the method call. That's something we'll see as well in the later video. And also we got arguments over here, obj, right? You want to compare the references between this and also obj, which is the arguments. Okay, that's how you can understand it. Of this and obj. And let me emphasize, this over here is the context objects of the method call. And the obj over here is the arguments, the input of the method. All right, hopefully so far you're still feeling comfortable about this equals method here. And when we say inherits, what we really meant is this accessor method is declared and defined in the object class. Automatically, every class that we customize by default is going to inherit this particular version. Okay, explicitly, you can see. You can see this particular equals method over here is going to be inherited to every class. Inherited to each subclass or child class, unless it's overridden or redefined. Overridden is a very special word for Java. Whenever we say overridden, we meant the method was redefined. Okay, so you can also think about more informally, it means redefined. Okay, let's now look at the two cases very quickly, and I'll explain the details in the later part of the module. So for example, you can see over here, for point v1, this class over here, we did not mention anything about the equals method. So that means implicitly, this version was inherited. Okay, so this means implicitly, the equals method from the object class over here, this version over here, is inherited. If you try to compare objects of type point v1 with another object of type point v1, it is going to invoke the default version that is inherited. On the other hand, over here, you can see we actually got one explicitly overridden version of the equals method. You can see we have the same header for the method. You can see it returns a Boolean and also has the same name equals and also has the argument type, also objects. So this one is the explicitly overridden version for the equals method. Okay, explicitly override the equals method. And as soon as you override this method here, this original version will be gone. It's no longer available. Meaning that if you want to say some objects of type point v2 dot equals just another object of point v2, in that case, you're going to invoke this version instead. Okay, it's really important. Okay, let me summarize quickly, and I'll go back to finish the bullet points in the slides. Let's say in this particular case, for this class over here, whenever you want to invoke the equals method on objects of this certain class type. In that case, it is going to invoke this version over here because they're simply inherited and you did not override it. On the other hand, if you actually want to invoke the equals method on objects of this particular class type, point v2, since the equals method has been explicitly redefined or overridden, so that means it is going to invoke this particular version over here. So that's a visual summary to show to you, but we're going to see exactly how this can be asserted in JUnit test cases as well. All right. And as for the details about the definition for this equals method, I will go into detail later in the module. Okay, so just bear with me. Okay, let's now go finish off a few more bullet points. And so this is the default version of the equals method. It will simply just try to compare the references between the context objects and the arguments, as I just explained. And then let's say P1 and P2, right? So that's point V1 over here, right? You can see point V1 over here, point V1. And that one there did not actually override the equals method that it inherits from the object class. So whenever we want to compare object equality between point V1 objects using the equals method, we're going to call this method that's inherited, right? So that one, if you call that, so that will be as if, for example, you can see P1 over here is, if you think about context object, if you talk about this method call here, and the context object is P1, which is this, and the argument P2 is basically OBJ. So it will boil down into P1 equals P2 according to this definition, right? I'm going to show you that on both the paper tracing and also debugger on the Eclipse. So for now, try to see if you can grasp the idea. All right. On the other hand, if you actually got another class, for example, point V2, in that case, if you say P1 dot equals P2, assuming that P1 and P2 are of type, let's say point V2, in that case, the equals method is no longer this version. It's going to be this version that's overridden. That's something we'll see as well. Okay, so very final points over here for this current video. Very often, when you define new classes, you want to redefine or override the inherited definitions of equals rather than using this default version, which will only compare references. If you wanted to do that, why don't you simply say P1 equals P2? In the first place, you don't need to really say P1 dot equals P2. All right, that's something I will try to emphasize again throughout the module. Okay, a final exercise for you for this current video. Let's say it's a very common mistake I actually saw students making. So let's say we got two primitive variables I and j, and then we have Boolean. Let's say we got some Boolean variable, the same value. We want to see if I and j have the equal values. So that's why I say I dot equals j. So here's a question for you: what will be the result of executing this fragment of Java code? Think about it and pause the video. All right, assuming that you paused the video and thought about it, the answer is we're going to get a compilation error. This fragment of Java code is not even going to be executed. So that's something I would like you to try. Okay. The reason is the equals method is actually inherited from the object class over here, and then only customized classes either from your projects or the Java library can actually use the equals method. Primitive types are not counted. So that's the principle. All right. Let's see what we have to say. The equals method is only applicable to reference types, either your customized classes in your projects or maybe the classes from the Java API library, either one. But it does not include the primitive types like an integer or double or float or character or Boolean. And what should you fix? If you just want to compare the values between two primitive types, you just have to use equals, right? That's something I want you to really pay attention to. You don't want to make such a basic mistake. All right, so that's about the very quick introduction and summary about where we're going for this current module. You just want to keep this particular diagram in your mind about either we overwrite or we do not overwrite the inherited equals method from the object class.